Hi, my name is Adam Mulia bin Zainuddin. My student ID is 2023881812.
Hi and Assalamualaikum. My name is Ratu Shakira binti Muhammad Sahabuddin and my student ID is 2023864658.
And hi, my name is Nur Nabila Fasihah binti Kamal Azmi. My metric number is 2023854454.
Okay, so this is our selective topic, which is finding extremum point and inflection point.
Introduction of the topic. What is inflection point? The point of inflection or inflection point is a point in which the concavity of the function change. It means that the function change from concave down to concave up or vice versa. In other words, the point in which the rate of change of slope from increasing to decreasing manner of vice versa is known as an inflection point. For concavity function, generally, when the curve of a function bends, it forms a concave shape. It is known as the concavity of a function. In graph function, two types of concavity can be found. First, concave up. If a curve opens in an upward direction or it bends up to make a shape like a cup, it is said to be concave up or concave down. Next, concave down. If a curve bends down or resembles a cap, it is known as concave down or concave up. In other words, the tangent lines underneath the curve if the slope of the tangent increase by the increase in an independent variable. What is extremum point? Extrema, singular extremum, are defined as the maximum or minimum values that a function takes at a point within its domain. These values help in determining the peaks and troughs in a function graph. Example, fx equal to negative x squared plus 4x plus 1. This function reaches its maximum when the derivative f prime x equal to negative 2x plus 4 is equal to 0, which occurs at x equal to 2. Plugging x equal to 2 back into original function yields the maximum values of f bracket 2 equal to 5. The importance of finding extrema in a function. Finding extrema within a function is crucial for a variety of mathematical and real-world applications, from determining the optimal solutions in economic and engineering to understanding the points of maximum curvature of geometric curves. Extrema plays a central role. For students, mastering the methods to find these points provide a solid foundation for further study in calculus, optimization, and applied mathematics. For understanding, the maximum profit point or the minimum cost point based on production curve can be determined by identifying the extrema of the relevant function. Similarly, in physics, identifying points of equilibrium within system often involves the calculation of extrema. How to find extremum point? To find extremum points, we need to follow these steps. First, find critical points, calculate the derivative of the function, set the derivative equal to 0 and solve for x. This will give you the critical points. Check if there are any points where the derivative is undefined. Next, evaluate function at critical points and endpoints. Evaluate the function at all critical points and at the endpoints of the interval. This will give you a list of possible extrema. After that, determine absolute extrema. Identify the largest and smallest values from the list of function values. These are the absolute extrema. After that, determine local extrema. Use the first derivative test to determine if each critical point is a local maximum or minimum. This involves evaluating the derivative at points near the critical points and determining if it is increasing or decreasing. How to find inflection point? To find inflection points, we need to follow these steps. First, find the second derivative. Take the first derivative of the function using the power of rule. Take the second derivative by differentiating the first derivative again using the power rule. Next, find candidate inflection points. Set the second derivative equal to 0 and solve for x. These are the candidate inflection points. After that, check the sign of the second derivative. Choose a value greater than and less than the candidate point. Plug its values into the second derivative and check if it changes sign. If it does, the candidate point is an inflection point. Verify the inflection point. Substitute the inflection point into the original function to ensure it is a valid point.
The problem statement for our assessment is, from given a function, we need to find the y-intercept, the critical point, the decreasing or increasing, and also the relative astronom. Besides, we also need to find the concave up and concave down, and also the inflection point. Lastly, we need to sketch the graph. So, how we want to solve the problem? Let me show you. First, we need to find the y-intercept. If you want to find the y-intercept, x must be equal to 0. And you need to substitute the x into the function given, and you will get the answer. Second, you need to find the critical point. First of all, you need to derivative the function. After you derivative the function, also known as f prime x, you will let the f prime x equal to 0, and you will get the x. After you get the x, you need to substitute into the original function, which is the function given, and you will find the maximum and minimum point. Third, how to find interval increasing or decreasing, and also the relative astronom point. Let me show you. First of all, you need to draw the number line. Second, you need to draw the table and input the test point into the f prime x. And we assume negative as decreasing, positive as increasing, and you will get the increasing and decreasing number. After that, you will sketch the graph with the maximum point and minimum point. Fourth, how to find interval concave up and concave down, and the inflection point f double prime x. Let me show you. First, you need to find the second derivative of the function, and you will let the f double prime x equal to 0. Then, you need to follow the step like before, which is you need to draw the number line and also the table. You will test point into the f double prime x. Then, we assume positive as concave up and also the negative as concave down. The second step, you need to substitute the x into the function given, and you will find the inflection point. In the last step, you need to sketch the graph of the function. First of all, you need to label the coordinate of y-intercept, minimum point, maximum point, and also the inflection point, and you will get the graph.
So, this is conclusion for this topic. In conclusion, from those problem statement that we choose, we know that how to calculate the equation by using the topic, which is finding the maximum and inflection points. We are able to know the meaning of inflection points and maximum points. From this, we also know the importance of finding maximum points in a function. Next, we learn how to choose the correct minimum and maximum point from the function using the derivative of function. We also learn how to use in order to find the function's inflection points. Besides, in this topic, we also know that they have concave function, which is concave up and concave down. We could see that the function changes from concave down to concave up or vice versa. Last but not least, from the problem statement that we choose, we need to sketch the graph. The interesting thing is we got a way how to sketch the graph properly using the all information in this topic. Last from us, these are my reference that we are used.